So, hi everybody. I hope you can hear me. Last minute microphone changes. Good. Good. Then let's get started with today's meetup. So, hello everybody. Welcome to today's March 2023 meetup. As usual, presented by us .NET Devs AT. Who we are a non-profit organization here in Vienna, Austria. That's all about sharing experience in the .NET world. We host these events once a month. Currently, one in person, then the next remote, then again in person. You can find us on YouTube, Twitch. We have a Slack channel, Twitter, soon Mastodon, and you have here QR code, and here is also the link in the chat. Yeah, thank you all for joining. I also want to thank our sponsors that makes possible to do these events. One is Rubicon and Theater Every. They support us monetarily that we can. One thing is that we can use StreamYard, what we are using for streaming, pay for and hardware for the in-person events. And the second, and JetBrains is sponsoring us with an 12 months product license giveaway for each meetup. Yeah, and we are doing this today. So how you can take part in the raffle? We will raffle them at the end of the event. Someone type JetBrains in the chat with the hash, and you will enter the raffle for that. Some quick news from the community. Some of you probably know we're part of the .NET Foundation, and the .NET Foundation has a virtual user group, which use them to announce, publish, virtual events around the world. If you need more .NET content, there you can find it. I think the screenshot is old. I think they're now at 3,500 members. Next thing, we have a event in Austria in May. May 12th is the Global Azure Austria conference. It's, as far as I remember, remote this year. Is always a cool event, and the call for papers is open at the moment, also, if I remember correctly. Next slide. Yeah, quick. We also start now recommend.NET content creators at the beginning. For the new ones, one is our own Flashiverse live stream, as our own Stefan, one of the co-organizers of the meetup, who is doing somehow regular streams. I forgot the current topic. It's not source generators. It's .NET Tools. It's .NET Tools at the moment. Then we have Claudio Bernasconi, Swiss content creator, more beginner content, and the last one is Nick Chapsas, UK content creator with a lot of various contents, a little more mid to high level, I would say. And with that, I'm done for the beginning, and I'm happy that we have today Poornima, I hope I pronounce it correctly, with us, and she is talking about, we will have an evening with her about minimal APIs. Thank you for being here. Question will be answered at the end. Please type them in the chat, and I will ask them for you at the end of the event. And with that, it's your screen.
Thank you, Andy, and thank you, the team at .NET Devs Austria, for having me as a speaker today. And thank you to all who have tuned in to watch me talk and do the session on minimal APIs. So without much delay, let's get started. There's lots to cover. I have put together a near 1 hour agenda, which I think will take us to the hour. That is, if I don't speak too fast or if I don't go too slow. Minimal APIs was introduced into .NET with .NET 6, and as with anything else in tech, we have lovers as well as haters. But today is all about getting to know minimal APIs. We'll build an API, and then we'll add more practical aspects to that API. I can't cover everything. Obviously, it's just 1 hour, but I have handpicked a selection of things which I think are valuable when it comes to API development. But at the end of the session, you will have an API which will have some of the real world capabilities that you would like to have in your API. So let us start with a demo. If you have seen my talk summary for the day, I speak about how you can take a console app in .NET and convert that into a minimal API endpoint. Well, we can make that happen. So what I have here is a console app. It's basically something which writes to the console. What we can do is we can turn the SDK into sdk.web. This loads all the MS Build targets for us. And into my program.cs, I'm going to drop in some code which I've prepared here. 4 lines of code, and I should have my minimal API up and running. And we can prove that point by actually going into this HTTP file that I've set up here and using the endpoint here. Sorry, that timed out. 5.6. Okay, this is the URL that I have here. There we go. So our web API is saying hello world to us. Let me actually quit Slack before we move on further. So that is our console project converted into a minimal API. So all it took me is 4 lines of code, and we have a minimal API up and running. So moving on, before we do anything with minimal APIs, let me introduce myself to those who don't know me. I am Poornima Nayar. I'm a freelance .NET developer based in Berkshire, UK. I'm a Microsoft MVP for developer technologies, and I'm also a Umbraco MVP. For those who don't know what Umbraco is, Umbraco is a .NET-based open source CMS, and my day-to-day job involves a lot of working with Umbraco, creating websites, web applications, etc., with Umbraco, and mentoring my team. I'm also a member of the .NET Outreach Committee, .NET Foundation Outreach Committee. And non-work me, I'm a mother. Most of my evenings go with my child, who is 9 years old. I spend a lot of time reading, and I'm also a student of Carnatic music vocals, Carnatic music being a stream of Indian classical music. And that's my Twitter handle, should you wish to connect with me on Twitter. When we say about minimal APIs, what it means is you can build APIs with minimal components, that is minimal dependencies, minimal syntax as you saw. That is minimal APIs in an essence for you. So if you have some takeaways for the day from this session of mine, I want this to be your number 1 takeaway. Building APIs with minimal components is what minimal APIs means. And why do we have minimal APIs in first place? Of course, we got this feature in .NET 6, and when .NET 6 was announced, this was probably the biggest feature that got delivered into ASP.NET Core as well. But even before we got it in .NET 6, there were other programming languages which had this pattern. So if you go into Node.js world, all they wanted was 7 lines to get their first Hello World API up and running. Similarly, for Python, something similar existed. We had something similar in Go as well. So under 15 lines of code, and all these programming languages have their first Hello World API up and running. Now, think about .NET 5 or .NET 3, where minimal APIs did not exist. If you create a ASP.NET Core web application, you would have this program.cs class. We would actually try and figure out what is going on in there. And then you would have your startup.cs class, where you configure your services and configure your middleware, all of that. So we have actually gone through how many? 14 plus 34 lines of code, nearly 48 lines of code, and that is taking away the namespaces that I have not included here in my screenshot. So 50 lines of code, and I still don't have my first Hello World API in sight. And that was the turning point which led to the birth of minimal APIs. I'm not going to talk eloquently about it. I am going to point you to Maria Nagaga's talk, I think back in 2021, where she speaks about the story that happened and that led to minimal APIs. It's fantastic. So minimal APIs, a huge point of it was to improve the developer experience for first timers, beginners, adopters of .NET, because all these programming languages or people coming from these programming languages into .NET, setting up a web API would be a mission for them. And with .NET 6, when there was this huge focus on improving the developer experience for developers and especially first timers and adopters, this was a point that kind of stood out, minimal APIs. The reason being, before minimal APIs, we had heavy boilerplate code that actually meant very high barriers to entry. And that led to minimal APIs in .NET 6. And what minimal APIs are, or how is it made possible? By three different things. Minimal hosting model that was introduced in .NET 6. That was, again, a path-breaking feature. Absolutely wonderful. And minimal hosting model is made possible by two different classes, web application and the web application builder, and the new routing APIs in .NET 6. That is the various different map methods. So minimal hosting model is three different lines of code, as you see here. So there's the web application that stands out, and of course the web application builder underneath the hood. But there is no two files, that is program.cs and startup.cs. All that 50 lines of code is kind of hidden away from you into much simpler APIs. And we have this 3 lines of code in program.cs, which acts as our application bootstrap. And this is further made possible by some of the nicer C# features that was introduced then, like top level statements, implicit usings, file scoped namespaces, etc. Now, if you want to have your namespace, your program class, your static void main args, you can still have that. But I personally feel this is much more nicer on the eyes. It reads very well. Now, if we go back into that console app and see what happens behind the scenes, this builder object that we have here is web application builder. That's the first class of the day that we spoke about. If I toggle the outlining and inspect what is going on, the builder object or the web application builder gives us access to a whole lot of things. We get access to environment, whereby we can read the variables, the environment variables. We get access to our IOC container. We get access to configuration, whereby we can have new configuration providers registered or even read configuration. We can have logging. We get access to web host as well as as the host, and we have the web application .build, using which it builds to a web application. And the app variable that you see here is the actual web application. And the web application implements a couple of interfaces for us. We'll go through the main things here. The application can start and stop, and we can pass in a cancellation token as well if necessary. We can have a middleware registered using the use method. And finally, the web application implements an interface called the iEndpoint route builder. The map methods that you see here is actually an extension on that interface. So if I go and inspect this method, you can see that it is all defined in this class called endpoint route builder extensions. And there is not just the map get, there is a map post, there's a map put, map delete. So basically following the pattern map with the HTTP verb. And they are all extension methods of this particular interface. And they take in a string pattern that is your route or your URL where your endpoint listens to. and goes in and executes a handler, which is known as the route handler in terms of minimal API. So what these map methods do is it goes and adds a route into the endpoint collection of your application. You don't need to worry about use routing or use endpoints. That is all done underneath the hoods for you. The minute you have your first map method in, use routing and use endpoints comes into play. And this route handler is what goes away and executes the code if there is a match found between the incoming request URL versus what you have in your endpoint collection. So what the map methods essentially do is it ties up your routing system to your route handler, which is your delegate. And this route handler here, I've just used a string that is getting returned to my client. It can be an asynchronous function. It can be a Lambda function, Lambda variable. It can be an instance method. It can be a static method. Lots of options are available for us. So that is the minimal hosting model and the minimal APIs, the basics covered. Now let us go ahead and start building a real world API. So for today, I have planned API, which performs CRUD operations and many other things on some event data. So events like meetups like this or conferences, which happen all around the world with tech communities. So I have created an API which acts on event data. I've got some initial setup done already because I wanted to use Entity Framework Core with SQLite. So starting with the object, the event model itself. So this is my minimal event class with the usual suspect fields like ID, name, description, all that. I've got my DB context here. And on model creating, I am seeding the database with some data, which is this JSON file that you see here. I created this using Mokru, so it is just lorem ipsum content. But hey, I've got 100 rows of data in my database. And that is my data seeder class, nothing special. In my program.cs, I have got my SQLite database registered into my IOC container. My DB context is registered. And to act upon the event data, I've got an events repository, which is here, into which I'm injecting my DB context. And it has got all the usual suspect methods again: get by ID, get all events, adding, updating, finding an event, all of that. So we have that repository, which is again registered as a scoped dependency on my IOC container. So first things first, let us start building an endpoint to retrieve all the event information, that is reading all event data. So I've got some code here, which I will drop in. So app.mapget. So I'm saying that, hey, this is an endpoint which listens on HTTP GET request, and the URL route template is /events. And I've got this events repository, which goes on to retrieve the data from my database using the repository, and I send the result back. So so that is our first endpoint. Let us now set up the basics, that is Swagger. Now I'm registering the Swagger services into my IOC container. We also need to have our middleware in place for Swagger, which I have dropped in. This is your ASP.NET Core Swagger you are familiar with. The point being, any middleware that you have, like Course or Swagger or any other thing, you can actually use that in minimal APIs as well. Now, if I go into my launch settings JSON and maybe amend the launch URL to be Swagger and run this, hopefully it runs. Woohoo, we have Swagger smiling at us. And if we try and execute this endpoint, it should get us the data back. So there's about 100 rows of content. You can go to great lengths with this improved pagination, filtering, all of that. But let us not talk about that now. This is all getting picked up from the project information itself. Using the Swagger services, you can configure and change most of these options that you see here. But that's a talk for a different day. I didn't want to bring Open API into this session today. We'd rather focus on the API part itself. So that is all good. But if you see here, we are not newing up our events repository. It is gathering that information from somewhere. And what is happening behind the scenes is there's inferred parameter binding going on. Parameter binding means you are taking the request data and converting that into strongly typed things that your route handler needs. And there's inferred parameter binding going on in the sense the route handler can go gather information about whatever it needs from various different places, like your query string, route template, your headers. The IOC container happens to be one such place. So our events repository being already registered to the IOC container, we don't need to new it up. It gets an instance from the IOC container, and using that instance, it can execute this method for me. And the result that I send back, it's always JSON. And if you see here, I'm creating something of results.ok and then events. So the events data, of course, it's sent back as JSON using system text JSON. But what I send back is an iResult object of type minimal events, because this results is a static helper class which sends an iResult back, and iResult is the result of an HTTP endpoint. And using the helper method OK, I'm saying that, hey, send back an iResult back to the client with 200 OK status, and the response data is the events itself that is serialized into JSON. So that is get all events. Likewise, we can have a get event by ID. So in this case, there is a route parameter ID, which corresponds to the event ID that we are seeking information about. Again, there's inferred parameter binding going on, and that gets bound to this variable in the route handler. We can also have a create event. In this case, it's a map post, and a post request always has request body. So there's again inferred parameter binding going on to gather this minimal event and form that model from the request body, because request body is one place where your route handler can go gather information about what it needs. So that we have our minimal event, which is to be created. So I create the event here, and if you see what gets returned, if there is an if there's an error, I'm just sending back a 500 internal server error to keep things simple for now. But this gets exciting and interesting. So what I'm sending back with when an event is successfully created is a 201 status code created, all good. But when we send a 201 status code back, what it needs is, in the response body, it needs the content of the newly created resource, that is our event itself. And in the response header, you need a location header, which specifies the URL of the newly created resource. So to get that URL, I am not hard coding the path in. So the path would be /events / the ID of the newly created event. Instead of hard coding that, I am injecting this link generator class into my route handler. Well, I'm not injecting it, I'm just mentioning it as a parameter here. It is gathered from the IOC container for me using inferred parameter binding. And this class helps me generate URLs behind the scenes for my endpoint. And using the get path by name method, I can generate the URL for me, where this string value that I pass here is what is called as the endpoint name of this particular endpoint. And I am also passing in a value dictionary for the ID, which means that at the end, when I have the response back, it will be this URL that I get back. So you don't need to hard code URLs in either. Likewise, we can have update and delete going on as well. Let us now try and run this and see. So let us try and post and create an event first, try it out. Let us say 300. Oh, 300. .NET meetup test description. I'm going to leave everything as test at test.com or some test data. Take this away and execute. So it should generate the event for me. And if you see the location header, it can give the URL back. And I've got my response data back. And if I go and run this and see to get the event information, that should all work. So, so of course we have our event created. So we can now move forward. I'm not going to go into the update and delete bit here. Back to our slides, we spoke about parameter binding. It can be inferred as well as explicit. Inferred is always nice because you don't have to just say where it needs to bind from. But your parameter binding sources can be route values, query strings, header, request body, the service is registered in the IOC container, or you can even have custom sources. There are examples of it in the minimal APIs documentation. Basically, you have to implement a class which has try, parse, or bind a sync, either of those. So these can be your inferred parameter binding sources. And if you want it to be explicit, like bind this particular variable from somewhere, you can have that too by using any of these attributes. So for example, you might have an HTTP GET request where you want it to force the parameter binding from the request body rather than query string. So then you can have the from body attribute on your route handler parameter. There are also special types which needs absolutely no um, explicit attributes. They are HTTP context, HTTP request and response, cancellation token, claims principal, link generator, as you have already seen. You can just use them in your route handlers. They will be gathered for you by the framework itself. And talking about responses, we have already seen how we can write a string response directly to the content. You can also pass in a type of T, which gets serialized to JSON using system text JSON. You can also have an iResult based response, which I showed you as well. So iResult being the result of an HTTP endpoint. You can have custom iResults as well. There are a lot of built-in iResults available, and if you want, you can have things like redirects as well. So if you want to create short URLs, Minimal APIs is a great choice for that. Now, Minimal APIs in .NET 7. Minimal APIs got a lot of features added when it came to .NET 7. I cannot cover everything today, but I have picked a few of them which I think are relevant, and we can have a quick demo of those too. So the first one we'll discuss today is file upload using iForm file and iForm file collection. So this was something that was completely missing in .NET 6. Now we have support for iForm file and iForm file collection if you want to upload multiple files. So let us see what we can have as a demo for that. Close this. Scroll down, and what we can do is, suppose, say, we want to associate images for your events. And we want to create an endpoint for that and then associate that uploaded image to your event. So let us see how we can do that. So that is the endpoint. It works with a map post. So it needs some goodness here. So that is the route template, events upload image slash the event ID. And the image file that you see here is an iForm file type, and that is my event image that I'm trying to associate. Then we have our int ID, that is the event ID, and of course our events repository. And I'm doing this work behind the scenes to upload the image. So if I now run this, I should have some information and I should be able to execute this endpoint. So if I go here, let us say the newly created event 300, choose file, castle illustration, execute. So that is my image uploaded because we have a 204 no content returned. If I now go back into my get event, sorry, not 200, 300, and execute it, I should have the event image that I just uploaded associated with it. So that is a quick demo of iForm file and iForm file collection, which brings us nicely to the second one, which is typed results. So if you go into the demo that I have here on this code, what you can see is that instead of result.no-content, I am actually returning a typed results.no-content. So type results was introduced in .NET 7. Type results existed as an internal class in .NET 6. And what typed results return is an actual implementation of iResult. Whereas with .NET 6 minimal APIs, it was always an iResult, which meant that if you want to test your minimal APIs, you would have to cast your types when you test it. So to make things easier, we have been given typed results. And it returns a concrete. That's the first difference. The second thing is that when we have this kind of multiple things going back, the Open API metadata gets preserved. So let us have a look what I mean. If I go into Swagger, um, and look at the OpenAPI schema here, it clearly tells me that the responses is a no content or a 404 not found, which is pretty useful. We can enhance it further, but I'm just telling you things out of the box. And we also have this generic unions here. And this is incredibly useful again, because this gives me compile time support. So if I type in OK here, it won't get accepted because we have that generic union there. And of course, OpenAPI metadata is being preserved for us. So that is typed results. Next, we will look into another change, that is binding arrays and string values from header or query strings, which means that I can send in a couple of query string parameters, and that can get converted to array uh, in my route handler for me. So for that, let us create an endpoint where you can say, search for multiple events at the same time, where the event IDs are passed in using query string. So for that, I've got a filter by ID endpoint, which kind of works like so: events filter by ID and IDs. And what you can see here is that the IDs get bound to an integer array, but the rest are the same things. So let me go and run this now. Filter by ID, try it out, add integer items, say, let us say 34 and 300. Execute. That should return the result back to me. There we go. So we have two results coming back. So that is one another change, that is binding arrays and string values from header query string. Now let us talk about a much more bigger feature that was introduced in .NET 7 for minimal APIs. For me, filters are where minimal APIs in .NET 7 got the biggest revamp. You can go really creative with filters, and to me, this is one of those features which takes it closer to controllers as well. The reason being, filters are basically business logic that runs before or after route handler execution. And you can go really creative, as I said, because you can do things like model validation, modifying request and response, logging, authorization. And if you want to completely short circuit route handler execution, that is also possible using filters. If you want to go have a look at modal validation using filters, there's a great example of it in MS Docs, but we'll look at something else today. So you might be wondering, how is it different to middleware? Well, there is a difference, because middleware runs on every HTTP request, while as filters, um, they are specified on specific endpoints, and they run only when the route is matched, as it says here. And endpoint filters can be applied to a single endpoint, a couple of endpoints, or even a group of endpoints, as we will see shortly. So let us try and go ahead with our API building process. Let us say I want to have an event code search now. So I want to search by an event code. And let us say that my API is getting popular, people want to use it, and suddenly there's a bunch of clients who wants to pay me so that they can support me with my API. And to such customers, I want to make sure that they are given an API key. Just to differentiate the customers, they have an API key. So let us make sure that these two endpoints are like that paid for endpoints, and they can be executed only when there is an API key in the request header. So let us start off with some code for that, which again I have got here. So there is the code. So if you want to add an endpoint filter into an endpoint, you start off with add endpoint filter method, passing in the delegate, which takes in an invocation context, which is of the type endpoint filter invocation context. And there is the next delegate, which returns an endpoint filter delegate. So in my code, the invocation context object gives me access to HTTP context, which means I can inspect the request or the response as well. And in my headers, I check for the API key. And if there is no API key, I'm sending a bad request error back to my client. So this is complete short circuiting of route handler execution for you. And then I can invoke the next filter or the route handler execution itself using the next dot invoke. So this goes and this passes the control to the next filter in the pipeline if there's another endpoint filter, or it just continues with the route handler execution. And then you have returning the result. Now, if you want uh, if you want code to be executed before route handler execution, you typically put that before you invoke the next filter. And if you want to if you want to execute some code after route handler execution, you put that normally after the next dot invoke has been done with. So in this case, this happens before route handler execution, and this happens after route handler execution. What I'm trying to do after route handler execution is add a custom header just so that I can prove the point. Um, so we will not add the endpoint filter here yet. We will wait for the next feature for that. But let us run this and see. So in my event filter ID, try it out. I know that I cannot pass in an API key yet because it needs some customization to have a special header shown in Swagger using I operation filter, I think. So let us just execute this and see what it does. It should say, yay, missing API key. Now, I've got this HTTP file here. If you're wondering what this is not a plugin. This is 17.5 Visual Studio feature. Let us now go and run the filter by IDs, which has an API key in the header. So that should run and give me my results back. Yay, so we have a result back. So that is endpoint filters for you. There is more things about customizing endpoint filters, having it as a separate file and having endpoint filter factory, the order of execution of filters, all that is there in MS Docs for you, but I'm covering the basic idea here so that you have a starting point. And that brings us to the last .NET 7 feature of the day that I'm going to discuss, which is route groups. As you can see, our program.cs file is growing in size, and you have that slash events added to every endpoint. And that is where route groups can come handy because you can organize endpoint with a common prefix. So I can move all that slash events into a single group and then assign my endpoints to that group. It helps reduce code repetition, which you will see. And what you can also do is things like authorization, things like endpoint filters, you can apply them on the group rather than at endpoint level. And what you apply on the group will kind of cascade down to every endpoint registered in that route. So let us go into the program.cs and add some code in place to have our groups in. So that is the grouping code. I have an events group which can be set up by app.mapgroup/events, and the paid group gets all what the free tier API gets plus extra endpoints. So what I am targeting is a nested group which comes off the events group so that I get endpoints in that too. And then I'm specifying again a map group on it with the endpoint slash. So we can now start rolling this out into all of our endpoints, events, here again here. Did I miss anything? No. Events group and events. That is all the events, the free tier group, and then we have the paid group. And we have the paid group here as well. Did I amend the events away? There we go. I did not. Okay, so we have our paid groups ready. Now, if I want to apply the endpoint filter to both the filter by ID as well as the event code search, I can move this code away into the group itself. So if we run that and see now, both my endpoints should now have the API key requirement. So if I run this with an API key, it should run and fetch me the event. The event code search also should have that API key. And without the API key, if I run it from Swagger here, where I cannot specify event code search at the moment, say RRR, it won't even execute because it is going to give a missing API key back. Now, this is jumped groups, but we can always customize it. We can move it off to a different group in Swagger itself with some customization, as I said before. So that is route groups. There are many more changes like better open API support, as parameters attribute. What else do you have? The pipe reader and stream support. All of that is in .NET 7, but I leave that to you to have a look at it later on. Now let us start building some practical aspects into our API. Now, this is a public API that I'm aiming for, and there could be clients which might actually abuse my API. And we want to make sure that my resources are protected so that there is no denial of service. Um, we might be using a very good SQL database, a highly performant one, but then again, there is a limit on how many requests it can handle. So what we can do is introduce some rate limiting. And we have been covered for that too using the Microsoft ASP.NET Core rate limiting package, which was bundled up with .NET 7. So we will implement rate limiting using this package today. There are 4 different algorithms of rate limiting with this package. The first one is the simplest, the fixed window limit, where you say that here is a window of say 1 minute, and in 1 minute, I'm going to allow 10 requests or 100 requests. And if a 101th request comes in, it is blocked by the system or queued up, whatever you want. And once that 1 minute has passed, the limit resets to again to 100. So that is the simplest way of doing it. The next one is a sliding window limit. This is a bit more nuanced than the fixed window because you have a window again here of say 1 minute. That is up to you to specify what the window is. But the window is divided into segments, say like segments of 20 seconds each. And the request limit is again on the entire window. So that is upon a 60-second or 1 minute interval, you can say allow 100 requests. And because window is divided into segment, the window keeps on moving or the segments keep on moving. And if there are requests in an expired window, those requests gets added into the pool back again. So that is sliding window limit. There is a good blog post when rate limiting middleware was announced. So I'll direct you to that in my resources so that you can get a better understanding of what I'm speaking. The next one is token bucket limit. As the name suggests, there is a bucket of tokens. And the bucket has a limit as well. Say, I have a bucket of tokens and the bucket limit is 10. Every time a request comes in, a token is taken off the bucket. And the setup is such that at regular intervals, the bucket is replenished with a set number of tokens. So say I have a limit of 10 on the 10 tokens of the bucket, and I am replenishing my bucket with 2 tokens every minute, say, for example. Now, if a request comes in, it takes a token away. So we have 9 requests left. But when it comes to the point of replenishing the bucket, instead of adding 2 to the bucket, only 1 gets added. So care is taken to make sure that your token bucket limit is not exceeded at any point of time. And finally, there is the concurrency limit, which enforces a limit on the number of concurrent requests at any point of time. There is no limit on the request over a period of time. So let us see this in action. Let's go back into our project. Let's close this all down. So first of all, the rate limiting is a middleware, and I've got the package already installed here. And in the program.cs, let us first start with having the middleware in place, which is here, which is done by registering the services. So with the rate limiter, I need a couple of using statements. I am specifying that I'm using the fixed window limiter here by defining a policy, and I'm configuring some options here. So this is the request limit. That is, I am allowing 10 requests, a maximum of 10 requests over a time span of 1 minute, and I'm not allowing for queuing. So if I'm allowing for queuing, it starts queuing up requests, and then you can say in what order should the queued up requests execute first. Is it the last request that KB should be executed first, or the first request that queued up should be executed first? So that is the middleware registered into my IOC container, and I need to actually add that middleware into my pipeline. And let us rate limit all the free tier endpoints, that is everything in the events group. That can be done using the required rate limiting method, passing in the policy that I want to use. So let us have this running. So if I now go and execute, say, event ID, let us try it out, say 300. I should be able to do 10 requests. I'm just going to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. We have a 503. Now, there is a problem with the way I have set it up, because if I'm thinking that my HTTP file here is another another client that is consuming my API, if I now go and run this, I get a 503 there too. So it's completely blackout for all the connected clients. So in this instance, we need to introduce what is known as partitioning, or a partition rate limiter. So with partition rate limiter, just like you have a cache key and a cache associated with that cache key, you can say that, hey, here is a partition, and for this partition, this is the rate limit. Remember, we might have the API key rolled out to the free tier as well at some point. So an example or a possibility is use the API key as a partition, or you want to use a host as a partition, or an IP address as a partition. That is all possible. But the way of doing it is like so. Let me have more using statements here. So I am using the add policy method here, again specifying the same name to keep things same. And I have the HTTP context here. The delegate takes in an HTTP context and returns a rate limit partition, as you can see here. So in my method, I am inspecting my headers for the API key, and I'm saying if the API key is null or empty, I am using like a common pool for all the known API keyed clients. But if I have an API key, I need a partition created for each API key. So if there are 10 API keys, you can have 10 partitions as well. So that is partition rate limiter. Now, if I run this, say 7, and we can quickly get to the 503. But if I go into this request here with an API version, sorry, not API version, it's API key 2. I know I have not implemented API key on my free endpoints yet. There's no filter on that. But this is just a demo. I know I'm aware of the bug there. But if I get this to 403, remember the API key is API key 2 here, but with API key 1, I continue to have the results delivered to me. So that is rate limiting for you with partition rate limiting. Let us move on to the next topic, which is structuring minimal APIs. Oh, hold on, I forgot to tell you something with rate limiting. So if you want to customize the result that you send back to your client, say like retry after X amount of time, there is a callback available called on rejected, which works only if you stop the queuing. If there is a queuing, the on rejected will not execute. But if you have your queue limit let to 0, you can have that call back to send back information to the client saying that, hey, you can retry after this amount of time. And that brings us to structuring minimal APIs. We started talking about minimal APIs and how it is all everything in one file, not spread across multiple files. But if you are wondering whether you can actually spread it across multiple different files, that is by all means possible. I am going to go with what is available to me out of the box without bringing any dependencies in to achieve this structuring. For that, I'm going to build a class, a static class with some extension methods. So let us add a class here called route group builder extensions, and add some code in place. So as you can see, it is a static class where I'm trying to extend the route group builder class. And there is a static class for the map events route group, which is the free tier, and for the paid events group. In the program.cs, we have the event group and the paid group, and they are essentially route group builders. So I'm trying to extend that with my own functionality. So what I can do here is everything that belongs to the event group, I can cut and move it into this map events route group, and the paid endpoints can go into the other method as well. You might be able to further refactor it down, but I just wanted to show you a starting point. And then in my program.cs, I can say events group dot map events route group and paid group dot map paid events route group. So that is some of the structuring done for us. We can take this a level further because we have this add endpoint filter here as well, which can be moved into its own class. And we can do that by creating a class called API key filter. And let me drop in some code as before. And I'm inheriting my class from iEndpoint filter, which is effectively what a filter is. I'm going to add the same code in place here. It's the same exact code that you saw before in that endpoint filter. But now I can replace this with a type of T that is API key filter. That is much more neater, if you ask me. It is cleaner and it is a bit more structured. My program.cs is not like 30,000 lines long. And if I execute it, there should be absolutely no functionality change. Everything should be business as usual. If I say get an event, say 5, it should get that for me. And I should be able to execute my paid endpoints as well, like so. So that is all working for us. Now, I used what is available out of the box, but there are some packages, some fantastic packages by the community members out there as well. The first one I think I've seen is Minimal API Discovery. The second one is Carter. I think Nick Chapsis in one of his videos also goes through a way of structuring minimal APIs. It uses reflection. I think all of these packages uses reflection to achieve the structuring. Each package has its own way of doing it. So go have a look. Again, I've got the links in my resources for you today. And that takes us to the last point of practical APIs today, which is versioning minimal APIs. Think about a RESTful or a web API. We always wonder how it can be versioned or what is the strategy to version it. Uh, Like everything in tech, APIs also evolve. I am pretty sure my API will evolve. The endpoint might not change, but my model might change. What each route handler needs might change. And everything, every time when I make a change, if my clients have to update their end too, then that means I have not considered versioning properly, because I'm introducing breaking changes by forcing my clients to update themselves as well. And it might not be even feasible when it is a public API and you have clients across the world. So versioning is that process where you can make your changes to API as transparent as possible without affecting clients. And we have a package uh, out there for us, ASP versioning HTTP. It is a .NET Foundation project, so go have a look. It's a very good comprehensive package, and it's been around for some time as well. But we will use this package today. With this package, there are 4 different ways of versioning your APIs. The first one is the query string. So if you just drop this package into your solution and do the bare minimum basics needed to have versioning in your APIs, this is the default method of versioning. It is assumed that the version information will be provided by a query string parameter, which is API-version. The second way is the header, wherein you pass your API version using a header called API-version. This is not a default method, but it can be set up. I will show you how. The third way, another usual way of versioning APIs is using the accept header or the media type. Alongside the accept header, when you send in the media type that you need, like application JSON or application XML or application JSON HAL, you pass in a version as well. So V1 goes alongside the accept header. And finally, the URL segment, where the version information becomes a part of the URL segment itself. If you ask me, this is the most rigid methods of of versioning APIs, because um, you can version APIs 2 different ways, or the strategy can be 2 different ways. I start off with the plan that I am going to have versioning for my API, so let us do it that way. Or API versioning is an afterthought. And in instances where API versioning is an afterthought, having the version information in your URL can be quite invasive, because with MVC, there is no way that the clients can send in an empty string in place of the version segment. So if you have slash events slash v1 or v2, they have to send in that v1 or v2 in the URL. There is no way they can send in slash events slash some slash blank slash something. That is just not possible. Whereas with the other 3 patterns, even if you have your API versioning as an afterthought with query string, header, or media type, what you can do is you can say that, hey, if the API version information is not sent by the clients, assume that version 1 or version 2 is the default version. So that option is available for the other 3 strategies, whereas for URL segment, that is not possible. So in my opinion, this is probably quite invasive. So feel free to use this if you are starting with an API which will have versioning from the word go. But I think my preferred choices would be query string or even the header. It is kind of silent. So in my project, I have the rate limiting already, so not rate limiting, the versioning already set up. This API Explorer package is to make it more open API friendly, because as you will see that when I introduce versioning, at some point Open API will completely go down. But then there is support for it, ways you can actually make things better. The code is in here. You need to wire it up. Again, I'll leave you notes for that. So in my program.cs, let us start with including versioning. So we first drop in our services with API versioning. And then we have our first versioned API. So this is how we start off with a versioned API, app.versioned API. This creates an iVersion endpoint.builder. And from here, I can create a new V1 version of the API. And then my events group and paid group will be nested groups of this V1 version. So that is V1, and this will be events group. That doesn't change. This, however, changes. And let us just get rid of this rate limiting for now. So with this setup, the assumed versioning strategy is URL query string parameter. So let us run this and see. And if I run this with the API version 1, and which is here, that should all be working for me. So that works. So that is version 1. Now, if you want to create a version 2, what you would do is you would have a V2 version. So as you can see, the HAS API version 1 is where it defines that this is the group corresponding to version 1. Likewise, we can have it for version 2. This would be V2. And I can copy the same entire thing here. This would be a events V2 group. This would be a paid V2 group. This would be V2. And this would be events V2 group here. And for my endpoint, I need to actually create a copy of this class, which I'm doing here for demo purposes. But in reality, you would have a lot more changes than just this events group V2 here. And again, V2 here. I have copy pasted, but in reality, your repository might have changes, your data contract might have changes. A lot of things can change for you, but this is just to prove the point that you can version APIs. So if I now copy this, have it here, events V2 group, paid V2 group, capital V, map events. If I can type, that is map event graph. There we go. So I am mapping the V2 events group and the paid group to my version 2 of my route grouping as well. So with this in place, API versioning with query string should work. What did I do wrong? The reason being, I have a Swagger error. What is it complaining about? Events filter by ID. So I have that somewhere duplicated. Version V1 version, events group, events V2 group. V2, that's correct. I think I've gone wrong somewhere. Events group, V1 version, events group, paid group. That's all good. V2 version, versioned APIs, V2 version, events V2 group. Okay, I've got something here which can help us fix this. Okay, you have to believe me on this one, but I will get back to you with the fix on this one. I got another project up and running with this, but the versioning should work, but let us comment this out for now and move on. So that is versioning, but if you want to combine two modes of versioning, that is query string as well as say header, you can have that combination as well. So that can be added via the options. So I'm saying here that, hey, with my default API version. So here I've got a couple of options. I'm saying that when a version is not specified in the header or query string, assume default version, and the default version is version 1. And with the API version reader, that is where I can combine the various different ways of versioning. That is, the first one is via the header, and the second one is via query string. So let us run this and see. So if I have this up and running here, the API 1 version should work. I cannot show you the API version 2 because it is slightly broken at the moment. I might actually try and fix it. Filter by ID. I know why this is happening. Might be this, because the endpoint names have to be unique as far as I know. 2, V2, V2, and do I have a name here? And now if I go and correct this, this should work. If not, we'll just move on. Okay, we have it working. So the error was that the endpoint names that you give per endpoint should be unique. So I added a V2 to every endpoint name, and that got it working. Swagger is broken. That is because of the introduction of versioning. We need a lot of support and code in place to get it up and running. There's documentation out there, and the code for that is also in here. We need some wiring up, basically. So that is versioning. Let us just see a demo of it before we try and finish off for the day. APIs.http. So I have my version 2 up and running here. And because I have this extra option here called, what is it? The report API versions, what it gives me is that in the response header, there's a special header called the supported versions that comes back to me. So that is a nice thing to do as well. So you can play with version 1 as well as with version 2. So that is versioning. So I am stopping with the features here, but you can have caching, you can have other methods of versioning. You can go to great lengths with making this as practical as an API as possible. But what are the use cases of minimal APIs before we wrap up? Minimal APIs are proven to be much more performant than web APIs. I don't have a concrete documentation that shows me or tells me why. Andrew Locke's blog series is great, but I haven't been through each and every part of his blog series, but do have a read of that. But high performant microservices can be an excellent use case for minimal APIs. Of course, prototype APIs, quick APIs are good, but I don't. I'm just mentioning here just for the sake of mentioning here. You can have as real world APIs as possible with minimal APIs, like shortening URLs. If you want to serve up static files using an API, that is also possible. A real world example of that would be if you have done gRPC, putting your proto files out there for someone to refer. That is a great way of using minimal APIs. And thus, having minimal APIs, what does that mean to about controllers and their future? Controllers are here to stay as much as minimal APIs are here to stay. It is all about having choice which way to go. You can start with minimal APIs and move to controllers if needed. And for some strange reason, if your controllers are going away or reducing in size, you can have them back into minimal APIs and gain some performance as well. But even then, there are some slight differences, and there is not yet that feature parity that you would like to achieve between minimal APIs and controllers. If you want custom model binding and custom model validation using these interfaces, that's not possible with minimal APIs. There's no built-in view rendering support, no support for binding from forms. You don't have OData support or JSON path support with minimal APIs. So this is where you would go with controllers for sure as of now, with like today as of .NET 7. But apart from that, I don't see a reason why you can't use minimal APIs. And that's the resources for the day. My code, I will check that in to the GitHub repository and provide you with a GitHub link in the same URL as well. But this should be all your resources for the day. And that is it from me. Thank you for sitting through a little bit of a demo mishap as well, but all good. I have learned a lesson. I should never copy paste code in real time. But yes, I can answer any questions if you have any. Yes.
Yeah, there are two questions as of now in the chat. First question is of dividing responsibilities. If everything is in a lot of classes by Monchigeo, I hope that was the question. It's
What
half an
about dividing
hour.
responsibility, as in your repositories and all that?
Um, I think at that point in time you had a lot of stuff in only in one single file there as when he asked the question.
So yeah, so if it is thinking about having services and things like that, as you have seen, you can actually structure it up. You can inject your DB context directly into your route handler if you want. I haven't gone that way. I have actually moved everything into a repository. You can have that. You can have that. So everything that is available out of the box with .NET, you can probably more or less use it with minimal APIs. Absolutely no problem there.
Good. I asked him. So the next one is about if you have any other interesting packages for rate limiting or.
That's a great
other things.
question, because yes, there is. The answer is there is. I think there's a package by Stefan Proden. I think that is the GitHub repository. Let me find that. Then there's a bit more nuanced, distributed kind of rate limiting system, if I'm not wrong. And I've seen that being mentioned somewhere as well. There we go. That's the one I was after. ASP.NET Core rate limit. Let me actually get that blog post out because I came across the name of that in Martin's blog post, which I have included in my. There we go. This is the one, ASP.NET Core rate limit. It's like a distributed kind
we
of
only
rate
see your
limiting.
slides if you want to
Okay, no
show
problem.
something.
I can ping that in the private chat, which you might want to put it out to everyone
Yes.
who are watching us. That is a package that you can make use of. But you definitely have the starting points of rate limiting with this package. This should take you quite a long way. So that is rate limiting.
Good. And then there are two additional questions. Few balance. Brilliant talk. Thank you. Best minimal APIs talk I ever seen. Better than Microsoft employee presentations.
That's
so
a
his first.
Thank you, however. Thank you so much. It's I should say comments like this makes all the time I have spent researching and building up this demo for you so worthwhile. Thank you so much, Lance.
Yeah, his first question is, can you touch a little bit more on the built-in logging?
Oh, built-in logging. Okay, that is a topic in itself, actually. I'll be very honest. So I'm going to direct you to the Microsoft Docs. How about we do this? I will point you to the Microsoft Docs using the URL that you see on the screen here. As soon as I wrap up, I'll go put some links in there for you to read up and have a look. Basically, it comes with console.logging, but you can have other logging providers, for example, Serilog, and then you can connect it to Sings and then go from there. So it's all taken care of you. And of course, you have it in your services, so you can inject into your classes, like the endpoint filter class that I just showed you. You can have your iLogger injected into that and then log things for you. So it's all available in the container. It's a part of what ships with .NET as well. So there we go.
Good. And here the second question. What's the tool that you're using in Visual Studio to run the API calls in the apis.htp file?
It's the latest, it's one of the latest updates. It's Visual Studio 17.5, that is Visual Studio 2022 itself. I don't need a plugin for it. So the version I'm using is version 17.5.0. There might be an update available, but we had this HTTP file support in Visual Studio Code, I think, as a package, and JetBrains Rider also have that. So this functionality is now available in HTTP. I haven't fully kind of gone into the um, to the to using it completely, but if you want to test your APIs without leaving Visual Studio and spinning up Postman, this is a great way. So I start off with the HTTP verb that I'm using, pass in the URL, and if I want HTTP header passed in, I can do like test and sorry, not there. So this becomes a header. Then you can have your request body. You can even have variables where this becomes common like a variable. So there's lots of things that you can achieve with it. It's a great tool. So if you Google for Visual Studio updates of late, you will land up in a document that comes with this. Visual Studio 17.5 had some great updates. This is one of my favorite ones. And they introduced dev tunnels as well, which is incredibly good if you want to let other people in and you want to kind of pair program and test. So have a look at that features as well.
Cool. Thank you. Yeah. Looks cool, the feature. And with that, I ask all the questions. They are in chat.
Yes.
Just
Or identity.
in the moment, always at in the moment I say we had all the questions, a new question comes. So the question is, it would be great if you could cover OAuth or identity in .NET Core for authentication and authorization. I would say that's 2 or 3 talks.
Yes, I tried to include that in my talk today, in all honesty. But as Andy rightly said, that is a topic spanning multiple sessions. Even if I start introducing the latest .NET JWT helper with this minimal APIs, I have to go to like ends to make it happen. I feel that this is itself a lot to take in for a day, which I was kind of worried about because I have to pace the talk well to the point you can understand it as well. But it is a vast topic. For example, if you look at Swagger today at the end of my session, it's broken. Um, I do have the code in place for that, but I can't really show you how to get it up and running, make that Swagger documentation that you see here really useful for the developers who are working on the same project with you. But then again, that is a talk for a different day.
Yeah. Good. That was the last question. 1, 2, 3. Yeah. Okay. This was it. So, I take over. So, thank you, Poornima, for being today with us and for giving the talk. As every speaker on our meetups, I will send you a custom-made coaster with our logo. Can take a little bit, but you will get it. Thank you all.
I'll be meeting Stefan in Oslo. You can give him the coaster.
Then I give it to Stefan. That's easier.
I know you are there. You just messaged me on the chat, so I'll see you at Oslo, and you can bring me the custom coaster when you attend NDC Oslo with me.
Yeah, that's easier, and I don't have to fill out custom forms. Good. Yeah. Thank you all for joining on YouTube and Twitch, and for the ones that are looking at the recordings. I thank again our sponsors, Rubicon, Theater Avery, and JetBrains. Now the interesting part is now we do the raffle, and you should now so at the stream see the window, and let's see who won. Rachel, if you're still here in the stream, please send me an email at team@.netdevs.at. I send it in the chat. Send me a mail, and I will send you in the next days the product code. And back to the slides. Yeah, there's again the email address. And yeah, if you want to host a meetup in the future, please contact us. We're always looking for locations. If you want to sponsor us, also get in touch with us. Agenda, the next one is on April 11th. It's about Maui by Roman Jacek. It will be an in-person event at Evolit. Announcement will go out in the next days. It's in person, but we will stream it also. So we include here everyone. May and June is still to be defined. May will be again remote only, and June will be in person. And yeah, please spread the word that we are doing these events. As much we are here, the much fun is there. And again, all the links, the one link where you can find every other link to our homepage. And the last one is for me important. We want to always make these events better, and for that we need your feedback. And it would be cool if you spend 2-3 minutes now to quickly fill out the feedback form and give us feedback if you can improve something for the future. That would be great. Yeah, and with that, I wish you a happy rest of the evening, day, depending on where you're located. For me, it's about 7:30, so near the end of the day. Have fun, and we see us the next time. Bye.
Bye. And thank you once again.